Boys and girls, this is Mr. Manise here again with another very cool video, and in this video I'm going to walk you through how to do each of the problems on the second quiz review for the back half of chapter 3 on triangles. And as always, my disclaimer is do not come to these videos and just watch me work the problems and copy it down. Work the problems on your own yourself and then come to the video and iron out any misunderstandings or errors that you may have made. Okay, so keeping with the tradition in my videos, I'm going to show you guys this cool Clemson GIF here, and this is the Clemson Tiger who's doing push-ups. Every time Clemson scores a point, a field goal, or a touchdown, then the Tiger has to do the same number of push-ups as the score. So if they score a touchdown at 7-0, he has to do 7 push-ups. And they score another touchdown, 14-0, he has to do 14 push-ups. So as a kind of a funny story, one of my good high school buddies actually ended up being the Tiger mascot in the late 1990s, early 2000. I believe he set a record for most number of push-ups in a season. So he was pretty cut. He was pretty muscular. You got to do, sometimes if they score up in the 50s or 60s, you're doing hundreds of push-ups in the same game. So I thought that was kind of neat. All right, so let's jump right into our quiz review, triangles. And in number 1, we have your favorite thing ever, proofs. We need to prove something about these triangles. Okay, so I want to prove that the measure of angle W, that W is congruent to angle Z. Okay, so I got to look at the given here. So in my proof, I'm always going to start off with my statements. I'll go ahead and write it out this time, then I'll abbreviate going forward. I've got my statements on the left and my reasons on the right. Make sure you guys can see that. All right, so one of the pieces of information they gave me was that WX, this line here, is congruent to ZY. Okay, so they're telling me that I can put a tick there on WX and a tick on YZ, WY, and, excuse me, YZ or ZY. So that means that these have the same length. So maybe this is a length of 3 inches and this is a length of 3 inches. They also tell me that WY, this side, is congruent to ZX. So I can put double ticks over here. Okay, so that's just the information that's given to me. So over here, I'm going to say that WX is congruent to ZY and WY is congruent to ZX. I always start with my given information in these proofs. All right, so now when we get to this part after the given, guys, I'm always asking myself the question, where can I add arcs and ticks to my diagram? Where can I add some additional information? Because right now I don't have enough information to say that the two triangles are congruent, which is what we're trying to do with all these triangle congruence postulates. And there are really 3 places or 3 scenarios where we've talked about adding stuff to our diagram. I'll just come out here to the side. One way, as we've talked about, is ticks in the middle. Okay, so if I have 2 triangles that are sharing a line, I can put a tick right there in the middle because of the reflexive property of congruence. Both of these triangles are sharing this line, okay, so it's going to be the same for both. Ticks in the middle. All right, the other place we've talked about adding arcs to our diagram is we have something like this, the hourglass, where I have 2 triangles that are touching, and then I can put arcs at my vertical angles. All right. Remember, I cannot add anything to my diagram unless the triangles are touching each other. They're sharing an angle. They're sharing a side. They're physically connected. Okay. The third place we've talked about adding stuff to our diagram is when we have parallel lines. So if I have parallel lines, then I've got this line cutting across through the middle. Now comes the little trick that I taught you guys to look for the Z. Okay, so here's the Z. I've got the top line, and here comes the Z down here, and then I have the bottom part of the Z. And in this case, of course, it's a backwards Z, but it's still a Z. Okay, so when these lines are parallel, I can always add arcs in my alternate interior angles. So I can put an arc there in the little corner of the Z, and I can put a little arc there in the corner of the Z. See, if we go back, this is our chapter 2 stuff, parallel lines. Okay, so here's the Z, alternate interior angles. Arc there and an arc there. Okay. All right, so I just want to cover that. Okay, so now I'm back to where can I add stuff to my diagram? Well, ticks in the middle. I've already used 1 tick, 2 ticks, so by default I'll put triple ticks here in the middle. Now, anytime I add something to my diagram, I have to explain that. So I need to say that YX, line YX or XY, doesn't matter, is congruent to itself. And the reason we need to say that is because this line is being shared between both of the triangles. So what I'm saying is this line is the same for that triangle as well as this line being the same for that triangle. And anytime I put ticks in the middle, it's always because of the reflexive property of congruence, RPC. Okay, now I have enough information to say that these two triangles are congruent. Now we're the boss. We can name these triangles however we want. I'll decide to name this triangle WXY. Okay, so I'm going to say triangle WXY. Now if I choose to go that path, I'm going through the single, through the triple. Okay, so that means it's going down here, it's got to be through the single, through the triple. So that's going to be congruent to triangle ZYX. Triangle ZYX. Okay, you don't have to use that same pattern that I chose, but that's just the one I chose. And how are these two triangles congruent? Side, side, side. Side, side, side. Side, side, side. SSS. But notice that's not what they asked us to prove. Your boss didn't ask you to prove that the two triangles are congruent. Your boss asked you to prove that the two angles are congruent. Okay, so if they ask you to go a step further in your proof, then not only do I have to prove that the two triangles are congruent, I've just proven that these two triangles are identical twins. So that means these two triangles have the same hair, they have the same nose, they have the same eyes, they are identical twins. So that means everything else, all the other corresponding parts have to match up. That means angle W is going to match angle Z. That means this angle here is going to match this angle here. All the corresponding parts have to match up. So now I can drop down on my next line of the proof and say angle W is congruent to angle Z. Okay, both of these identical twins have the same hair because corresponding parts of congruent triangles are congruent. Okay, everything else about the triangles matches up. C, P, C, T, C. Corresponding parts of congruent triangles are congruent. They're identical twins. All right, number 2, another proof. Given that angle ONL, okay, put your pencil on it. ONL, okay, ONL, got it. That angle is congruent to angle MLN. Put your pencil, your finger on it. Angle MLN, MLN, got it. Okay, those two angles are the same. And then it says angle O and angle M are right angles. They already have the boxes there. Prove that line LM, prove that this top line is the same length as NO. All right, so once again, over here in my proof, I'm not going to write statements and reasons. I'm just going to write S and R. Okay, I'm going to write down the given. In this case, just for sake of time, just for the sake of the video, I'm just going to kind of circle this. And let's draw a little arrow right there. Right there. And I'm just going to write given. All right. So now, once again, I'm down to my next step. Where can I add stuff to my diagram? Do I have any vertical angles? Do I have alternate interior angles or parallel lines? No, but I do have ticks in the middle. Okay, so I'm just going to add a tick right there. So I need to say that in my proof. I need to say that Ln is congruent to itself. Ln, Y, reflexive property congruence, RPC, always RPC for ticks in the middle. And now do I have enough information to say that the two triangles are congruent? Well, yes, I do. Okay, first of all, I have angle, angle, side, but also when you see these right angles, what I was just about to say is when you see these boxes, guys, that ought to be a red flag. Hey, blinking red light. Maybe this is hypotenuse leg. Maybe this is HL. However, I do have ticks on the two hypotenuses since it's shared, but I don't have any ticks on the legs. So I can't use HL in this case. But I do have angle, angle, side. Angle, angle, side. When I see two pairs of angles, I'm immediately thinking, okay, this is either an AAS or ASA. Okay, but notice this tick is not in the middle. If this tick were down here, I would have angle, side, angle, but I don't have that. So throw ASA, throw this guy out the window. Okay, so now it's either AAS or it's nothing. Okay, and since I'm doing a proof, we're never going to have NEI in a proof because we're trying to prove something. Okay, so that means it has to be AAS. So I have angle, angle, and then the side. All right, so once again, I can name these triangles however I want. I'm going to go triangle LMN is congruent to triangle NOL. Okay, triangle LMN is congruent to triangle NOL. And how are those two triangles congruent? They're congruent by AAS, angle, angle, side. All right, is that what they asked us to prove? No, they asked us to go one step further and say, why did these two people have the same height? Well, because they're identical twins, that's why. Why do these two lines match up? Well, because the triangles are identical twins, that's why. Line LM is congruent to line NO because identical twins, C, P, C, T, C. Corresponding parts of congruent triangles are congruent. Okay, I'll just take a break from the proofs. Is DE congruent to DF? Explain. Okay, DE, is this line, is that the same length as this line? Well, in order for that to be true, that would mean that this would have to be an isosceles triangle, right? I'd have to have ticks on both of these guys. And in order for me to determine whether it's an isosceles triangle, I need to know what the base angles are. I know that the base angles of an isosceles triangle are the same. So the question is, this is 61, is this 61? And the way to figure out the third missing angle is the triangle sum theorem. All three angles add up to 180 degrees, so I simply take 180 and subtract my two angles. 180 minus 58 minus 61, and oh look, yes, I do get another 61. So this other base angle is 61. So yes, I can say, oh, okay, if the base angles are the same, that means the legs have to be congruent. So the answer to this question is yes, but now the question is it the regular isosceles triangle theorem or is it the converse? Okay, remember, when it's the regular isosceles triangle theorem, then they give you the ticks, and that allows me to put arcs at the base angles. The reverse of that is if they give you the base angles, and that allows me to put the ticks, and that's what we've done here. We figured out the base angles, and that allows me to put the ticks. So this is yes by the converse of the isosceles triangle theorem. I'm not going to write all that out. I'm just going to say ITT. Yes, by the converse of the isosceles triangle theorem. Number 4, what's the value of x? This is an isosceles triangle, tick and a tick. So I know that base angle has to be congruent to that base angle. So I'm simply going to set these two expressions equal to each other. So I have 3x plus 28. I'm going to set that equal to 5x. And I just solve. Subtract 3x. 28 equals 2x. Divide by 2. X is equal to 14. That's pretty easy. All right, number 5, isosceles triangle XYZ has a base of XY and the measure of angle Y is 34. What is the measure of angle Z? Boys and girls, in geometry, you must draw things out. Don't ever try to do something like this in your head. I need a diagram. I need to get my bearings straight. So let's draw ourselves an isosceles triangle. They tell me it's isosceles, okay? Let's put a tick there and a tick there. They're telling me that the base is xy, okay? So that means that x and y have to go here. That means z is up here. They say the measure of angle y is 34, okay? If this guy is 34, then the other base angle also has to be 34. And to find z, the vertex angle, I simply add these two together. 34 plus 34 is 68. And I simply subtract 68 from 180, and that gives me 112 degrees. So z is 112. Oh, sorry, can't see that. 180 minus 34 gives me the third angle, 112. Okay, number 6, are the triangles below congruent? Always, guys, where can I add stuff to my diagram? Can I add vertical angles, parallel lines, z, ticks in the middle? I have ticks in the middle. Okay, so if I were to draw the triangle on the left separately, if I would just come out here and draw this, box, double ticks, tick, oh, again, sorry, you can't see that. If I draw the left triangle down here, I have A, as, that doesn't work. That's not one of them if you spell a cuss word forwards or backwards. However, when it is a 90-degree right angle, I can use the hypotenuse leg theorem. And that theorem says all I need is a box on both triangles. I need two 90-degree angles. I need a tick on the two hypotenuses, which I have, and I just need a pair of ticks on one of the legs, which I have in this case. So the answer to this question is yes, they are congruent by the HL theorem, hypotenuse leg. Okay, number 7. Oh man, another proof, really? Yes, another proof. Proofs are wonderful. You're building logical thinking skills. I talk about this all the time about how proofs, think about a court case. If we're a lawyer, we're trying to present to the judge, or we're trying to present to the jury. We've got some evidence. We've got some fingerprints on the gun. We've got some evidence laying around the apartment where the crime was taking place. We're trying to prove something. I got to take some evidence, some given information, and I've got to logically go through a series of steps to get down to the end so I can present to the jury, this is why this person is innocent or guilty. Okay, so you're building logical thinking skills here. Okay, so here's the information that they've given me. I've got my statements and my reasons. They tell me that ON is congruent to ML. Okay, so a tick on ON, a tick on ML. Okay, I got LP and PN. So double ticks on LP, double ticks on PN. And then they tell me that OPN is a right angle. All right, now they don't want me to go, I'm not going to use CPCTC in this proof because all they want me to do is prove the two triangles are congruent. Just prove that they're identical twins. Don't go a step further and say that they both have brown hair. Just show me that they're identical twins. Okay, so fine. So once again, I'm not going to copy down all this given information for sake of time. Given. All right, so now I've got to write down some information. Where can I add arcs and ticks to my diagram? Okay, well, first of all, I've got a box here. Okay, so I can say that there's got to be a box here because they're vertical angles, correct? So I'm going to simply say in my proof, I'm going to say angle LPM, angle LPM is equal to, I'll just say that's equal to 90 degrees, okay? And the reason why that is because these two guys are vertical angles. So the vertical angles theorem, I'll abbreviate VAT, vertical angles theorem. Now, do I have enough information to prove that the triangles are congruent? Yes, I do, because we just talked about if I see two 90-degree angles, that's a blinking red flag, that's a blinking red light. Hey, maybe this is HL. I have ticks on the two hypotenuses, and I have a pair of ticks on one of the legs. So that's enough. I can now say that triangle, I'm just going to go back over here and just copy down what they wanted me to prove. So I'm going to say that triangle OPN is congruent to triangle MPL, and the reason for that is hypotenuse leg, HL. Again, there's no CPCTC because we're done. We have proven to the jury that these two guys are identical twins. We're done. Okay, number 8, overlapping triangles. Overlapping triangles. All right, so let me pull out another color here. So guys, with these overlapping triangles, it's definitely going to be helpful to you to color code these things, to redraw and separate out the triangles. They want to know what is the common angle in triangle LMP and LNO. You've got to pay attention to which triangles they're asking you about. I'm going to do these in these random beautiful orange and purple colors. LMP, okay, and LNO. So not only am I going to color code these guys, I'm actually going to come out here and redraw them. Now you guys can look at this and you can figure out what this common angle is, but maybe maybe on the test or quiz you're going to have a kind of a complicated diagram where you're really going to need to draw these out, guys. All right, so MLP, P, and NLO. Okay, so now that I've redrawn these two triangles, now I'm trying to figure out which angle do they both have. Okay, well obviously it's going to be L. Purple triangle has an angle L, orange triangle has an angle L. You can look at these two and see literally where do I have an angle that has both purple and orange at the same time, and you can see clearly up here at the top angle L is the angle that's being shared. Okay, so my answer is angle L. Okay, but you got to redraw these things, guys. If they're asking you to find which two triangles are congruent by SAS or something like that, you got to redraw these things or color code. All right, one more proof. One more proof. This one's a little bit something to this proof. Got to think a little bit here. All right, so I'm going to have my statements and my reasons. Again, I'm just going to copy all of this over here to the given. And they tell me that RU is congruent to TS. So a tick on RU and a tick on TS. V is the midpoint. Now what does that word, what does this word right here mean? Midpoint. Midpoint means the halfway spot. Or essentially I'm cutting a line in half. So V is the midpoint of RT. Okay, so here's RT where my pen is. V is right in the middle of R and T. Okay, so if it's in the midpoint, that means I can put ticks on RV and ticks on VT. Okay, correct? Because V is the halfway point. All right, so I need to say that in my proof. I need to say that RV is congruent to VT, Virginia Tech. And the reason for that is because V is the midpoint. Okay, so you could either say V is the midpoint, you could say definition of midpoint, you could say V is halfway between R and T, however you want to convey that information, that you understand that V divides RT in half. All right, and then they tell me that V is also the midpoint of US. Okay, so here's US, and V is in the middle of that guy. So that means I can put triple ticks on UV and triple ticks on VS, because I'm splitting this line in half. So once again, I need to say that UV, I need to say that this line is congruent to this line, VS, because once again, definition of midpoint. Or V is the midpoint, however you want to say that. Okay. Now it's asking prove the angle RUV. Okay, I'm going to do this in a different color. RUV. I want to prove that that angle is congruent to TSV. TSV. I want to prove that those two angles are congruent. Okay, how am I going to do that? Well, I need to be able to say that two triangles are congruent and then be able to use CPCTC. Okay, so what I'm looking at here, guys, maybe I should do this in red. So what I'm focused on right here, guys, are these two triangles in red. I'll throw in some Georgia Bulldogs. How about that? Just for you guys. So I'm looking at these two in red. If I can prove that those two red triangles are congruent, then I can say by CPCTC, then all the other arcs match up. These two angles have to match up. These two angles have to match up. So I do have enough information to say that the two red triangles are congruent. So I'm going to say that triangle UVR, I'm going to go UVR, that's going to be congruent to triangle SVT. SVT. Now there are actually two ways to prove that the two red triangles are congruent. I can either use side, 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 tick, 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 or if you guys wanted to, if you wanted to go a step further and put arcs here at vertical angles, you could say that angle SVT and angle RVU are congruent by that. Okay, but that takes an extra step. So I'm perfectly fine just leaving it as SSS. But I'll put in parentheses. You could have also used SAS, SAS, with the vertical angles. And now that I've proven that the two red triangles are identical twins, now I'm ready to say that they have the same hair color, the same eyes, the same height, everything else matches up. Angle RUV matches up with angle TSV. Why? Because they're identical twins. CPCTC. Corresponding parts of congruent triangles are congruent. Okay. All right, so that's it for the proofs. Let's get down a couple more algebra problems here. Find the values of x and y. What kind of triangle is this? This is an isosceles, because I got the two ticks. If that's a length of 4, then x has to be 4. So x equals 4. And then if this is 50, if my vertex angle is 50, I simply subtract that from 180. That gives me 130. So these two angles have to add up to 130, but they're the same because it's an isosceles triangle. So I can put arcs there and there. So basically all I have to do is divide that 130 in half. 130 divided by 2 gives me 65. So both of these base angles have to be 65 degrees. Okay. Number 11. All right, so all they've given us is this outside obtuse angle, which is 125. So anytime two angles form a straight line, I'll draw this up here. Anytime two angles form a straight line, they have to add up to 180. So if that's 125, I'll just subtract 125 from 180, and that gives me 55. So x is 55 degrees. Okay. X is 55. Now, if x is 55, what is this? If I turn my paper this way, this is another isosceles triangle. This is my vertex angle. If x is 55, then this guy has to be 55 because why? Vertical angles. They're both vertical. All right, so now if the, sorry, that kind of looks like a 6. 55, that's more better. Okay, so if this vertex angle is 55, I have to subtract that again. I have to subtract that from 180, and that gives me 125. So once again, these two base angles have to add up to 125. They're the same, so I'll cut that in half. So y is going to be equal to 62.5 degrees. And yes, of course, we can get decimals. Okay, home stretch here, guys. The last one here, number 12. Circle each pair of triangles that are congruent by HL. So remember, I have to have ticks on the hypotenuses, ticks on a set of legs, and two 90-degree angles. Okay, got the two 90-degree angles. And how do I know which one the hypotenuse is? Yes, it's the longest leg, but a lot of times with these kinds of problems, it's hard to see which one the longest one is. So it's just across from the 90-degree angle. So this is the hypotenuse, it's opposite the 90-degree. So I've got a tick on the hypotenuse, tick on the hypotenuse. I can put ticks in the middle. So yes, I can use HL for those two. What about the next one? I've got a box here. I can put ticks in the middle. This is a hypotenuse, it's across from a 90-degree angle, but is this a hypotenuse? Is it across from a 90-degree angle? I don't have a box here. But I know it's a box because these two angles have to add up to 180 degrees. They form a line. So if this is 90, that guy has to be 90. So yes, I have ticks on the hypotenuses, a tick on one set of the legs. So yes, this is also congruent. These two triangles are congruent by HL. This one, nothing. I don't even have any ticks. I can't add anything to the diagram because they're not touching. All right, they're not connected. Over here, these are connected, so I can add some stuff. I can add vertical angles here. But once again, I don't have any ticks. I do have two 90-degree angles, but I can't add ticks here. So no, this is not, these two triangles are not congruent by HL. All right, so that's it for this video, guys. Hope you enjoyed that, and I wish you good luck on the quiz, and we'll see you on the next video.